So here we are on day 2 of going over our exponents. If you were present in the in the M through Z class on Thursday, you've already done this, but if you've been at home, this video is for you, as well as the folks who are with me today. So we're going to go over the exponents quiz assignment that you took on, I don't know, sometime earlier this week of November the 6th.
Christy Brown, can you please Digit 100?
And we're going to focus on strategies and how to make these questions go by quicker. Also ways that you can kind of work the system a little bit and not necessarily have to answer all of the parts. So for question number 1, we have 4x cubed plus 3xy squared, times 3xy squared times 2xy squared. And you're trying to figure out what that's equivalent to. On these questions, really the fastest way to do this is to work it in pieces. When you're multiplying all of these parts, your x's are going to only combine with x's, your y's are going to only combine with y's, and your coefficients are going to only combine with coefficients. So you work each part one at a time and eliminate wrong answers after each step. So for example, first I'm going to start with 4 times 3 times 2. 2 times 3 is 6. 6 times 4 is 24. So I know that A and B are out because they don't start with 24. So then typically, while I'm looking at these answers, I would want to look at the x's and the y's and see where the differences are. I've got x's with 5 and 3, and I've got y's with 4 and 6. I only have to do really one of the other ones, possibly. So let's look at the x's. You got 3 and 1 that's understood here and 1 that's understood here. So there's 5. And then your y's have 0 over here, plus 2 is 2. Plus 2 is 4. So D is going to be your correct answer for that. If you didn't have D, go ahead and mark it. Folks at home, I've already told the folks in class, you're able to open your answers and edit them. So please do that. That's kind of the whole purpose of this video, is so that we all end up with a 100. So D on number 1, 24x to the 5th, y to the 4th. When you're multiplying like bases, you add up the exponents. That's the rule that you use. Next, for a real number, m, 2m cubed, all raised to the 4th equals blank. So on this one, I didn't write anything down for number 1, so I'm going to change that to 2. On this one, you have to realize that when you have an exponent outside the parentheses like that, it gets distributed in to all of the other terms. Now, terms are multiplied here, and so each one is going to get a 4 behind it. So 2 to the 4th, and m to the 3 times 4, or 12th power. So personally, I think that's faster to multiply the exponents. And so I'm going to check the m's first on this one. And you can see I've only got 2 answers that has m to the 12th at the end. I've got B and E. So I've got a 50-50 shot just based on doing that piece of the problem. And then common sense is going to tell me that if I take 4 2's and I multiply them together, I'm not going to end up with 2. So the correct answer is going to be E, 16. And you could check that if you want to. 2 times 2 is 4, times another 2 is 16. Or sorry, times another 2 is 8, and then times another 2 is 16. So that is number 2. And y'all stop me if you have any questions. You can forget this for any real numbers business. They're always going to be real numbers. And then is equivalent to, you're just picking the ones that are the same. Same process that we did on number 1, though. Just take your coefficients and multiply them and then check and eliminate answers. So number 3 has 10 times 5 times 2. 5 times 2 is 10. 10 times 10 is 100. Automatically, I have a 50-50 chance now of getting it right because I've eliminated 3 of the wrong answers that simply added those numbers instead of multiplying them. Then my A's both have different coefficients. So once I figure out how many A's I am multiplying together, I'm done. So A squared, that's 2 A's, and a 3rd A, and a 4th A. So A is your answer, 10A to the 4th. If you wanted to check the B's, that's fine, but there's going to be 5 of them. You don't have to work the whole problem. Save your seconds so you can use them on those harder problems. Okay, next, you're simplifying this. Notice all of these phrasings are the same. It's like for any real numbers, and then there's a part that says which is equivalent to. That's pretty consistent. Don't take your time reading that. just jump straight over here and start simplifying when you see a problem like this. So we're going to take this -2 and we're going to distribute it just like we were doing in one of those earlier problems. So we have 1 over 4m, oops, sorry, hit the projector, to the 3rd, all of that to the -2nd. Now, personally, I distribute before I start rearranging my stuff. So I'm going to distribute the -2nd power here, here, and here. I would do most of this mentally, so I'm writing down right now way more than I would on an actual ACT, just to show you the process. So this will be 1 squared, which is 1, and the negative exponent means that it's in the wrong place in the fraction. It's not happy with its location. So we're going to switch spots. So this 1 to the -2nd power needs to become 1 in the denominator. So I'm going to set up my next fraction. I'm going to put the 1 in the denominator. Could you leave it off? Yeah, sure. But I just usually go ahead and write it just in case it's the only thing that ends up down there. So then we have the -2nd power that gets applied to this 4. Well, the negative power means it's going to move up. 4 squared is 16. So there's that. M to the 3rd times -2. So 3 times -2 is -6. So -6 moves up to +6. And then over 1 is just a whole number. So 16m to the 6th is E. Now, if I'd been thinking, I should have just stopped with 16. Sorry. Because once you've got 16 in the top, there's only one answer that has 16 in the top, and it's E. So you could have been done with that. Okay, 6a to the 5th all squared. We're going to distribute that squared. What is 6 squared? 36. So it's automatically B or D. And then you have A, and the question is, do you add these or do you multiply them? If you add them, it's A to the 7th. If you multiply them, it's A to the 10th. So when you multiply, we raise a power to a power is when we multiply. So it's going to be D. Let's say that you weren't sure. Another kind of strategy for getting the right answer. You know 6 squared is 36. You know there's a 50-50 shot. It's only going to be B or it's going to be D. Pick a number to be A and see if, let's say that maybe A is 2. 2 to the 5th squared, like it is up here in the problem line. See if that is equal to A to the 7th or A to the 10th. So that would be 2 to the 7th and 2 to the 10th when you plug in a 2 for A. Only one of them will be equal. And that's another way that you can figure out which one of these it is. Same thing with the previous questions. We'll see some more of them. You don't necessarily have to pick a number to be each variable, just one variable, at least one at a time. Here they give us some numbers for X and Y. So X is 2 and Y is -1. So we're going to take 1/3 and raise it to the 2nd power. Subtract more parentheses. 1/2 gets raised to the -1st. So once again, distribute first. The 2 goes there and there. The -1 goes there and there. So 1 squared is 1. 3 squared is 9. And then this -1 means that I need to flip this over. And then it's just raised to the 1st power. So I just flip over 1/2 and it becomes 2. Now, a lot of folks are not great with fractions, but look at what you're doing. You're taking basically a -2 and you're going to add 1/9. I usually start with the bigger number and then I take away the smaller number. It just helps me estimate it a little better in my head. However you want to do it, it's fine. That's just how I do it. So 1/9 minus 2, that's going to be pretty close to -2. So let me see which answers I have are pretty close to -2. Also, the denominator is going to be 9. This 2 can have any denominator that I want it to be, and I want it to match this one. So I'm looking for a number with a denominator of 9 that is close to -2. So it's going to be A. That's the only one with a denominator of 9 that's just almost -2. So some estimation there. You could also type it in your calculator, but estimation can be faster. Okay, so here we distribute this 5 to all 3 of these. Personally, I'm going to check the X's and Y's first. And because I'm pretty quick at it, right? We've been doing this for a little while. I'm going to check them both at the same time. So this should be x to the 10th, y to the 5th. Let's see what all we've got. X to the 10th, y to the 5th. I've got A, C, and E. Okay, so let's see how they're different. I've got 1/10, 1 over 32, and 5 over 32. Well, when I raise 1 to the 5th power, it's going to be 1. So E is out. 2 times 5 gives me 10. So it's got to be 32. And if you want to check it, 2 times 2 is 4, times 2 is 8, times 2 is 16, times another 2 is 32. So C is your correct answer on this one. Okay, m over m square root of m is equivalent to which of the following? So this is something that you might be doing in Algebra 2. In Algebra 2, you talk about rational exponents, so exponents that are fractions, and you learn that the square root is equal to the 1/2 power. Personally, that's how I think is quicker to solve this, unless you've just done a whole lot of rationalizing a denominator, then this is probably going to be the way you want to go. So I'm going to take m to the 1/2 power, and then on the top of my fraction, I have a single m. And I'm going to just treat these exponents like I'm simplifying them, because that's really all I am doing. So this is 1, this is 1/2. I'm going to subtract them and leave it where the number is bigger to begin with. So 1 minus 1/2 is 1/2, and it's in the top of the fraction. So that's going to be D. Oops, you can't see that. There it is. It's going to be D, because again, the 1/2 power is equal to the square root of something. If you weren't sure, pick a number and plug it in. But pick smart numbers, right? You know you're going to be taking the square root up here, so don't pick something like 2. You can't do the square root of 2. You could do the square root of 4. So m is going to be 4. Here's how that would work. I have 4 over the square root of 4. This is 2. So 4 over 2 is 2. And then I'm going to plug that in and see which one is going to give me 2. A is just 1, so that's wrong. B is just 4, so that's wrong. C is 4 squared, which is 16. D, square root of 4 is 2. So that's how you do the plug-in numbers for these as well. We simplify these, and once again, you're going to check check the answers one piece at a time. So 2 over 6 is going to be 1/3. A is possible, B is possible, C is out, D is out, E is out. It's one of these first two. Now, as long as you're confident about your A's or your B's, you've got it. You don't have to do both of them, just the A's or the B's. So this is a 5, this is a 3. The question is, do you add them or do you subtract them? Well, if you're dividing, you're going to subtract them. So that's B. Correct answer is B. Simplify. Again, one piece at a time. The square root of 25 is 5. So it's either C, D, or E. The square root of x squared is just plain old x. So that means it's E. All of these other x's, this one is raised to the 6th power. This one is raised to the 12th power. So I hope what you're seeing is if you know these rules, these are some quick places to pick up. That one was E. These are some quick places to pick up some points on the ACT if you know these rules pretty well. Okay, let's go here. Where x is 4 and y is 27. Okay, so once again, 9 over 18, I don't need x is 4 and y is 27. That's going to be 1/2. So let me check this out. Oh, well, I guess I do need to plug those in. Sorry. Wrong problem that I'm thinking about. So I'm going to go ahead and leave that as 1/2 because that is simplified. X is 4, y is 27. And then 4 to the negative 1/2 down here, it's like the square root of 4, which is 2, and then it's negative. So it's got to move up. So this is going to be a 2 up here instead of this. Then y to the 1/3, the cubed root of 27 is 3. You could do that in your calculator. You could either type in 27 to the 1/3 power, or you could use that yellow button And then I think you go like 2 rows over from the 4, and there's a little caret. Caret looks like that. And what that'll give you is it'll give you a box and a radical and another box. And you can type in the cubed root of 27 and it will return 3. So I'm just going to simplify. That 2 goes with that 2. This 3 turns that 27 into a 9. 9 times 4 is 36. So B. This one is not great for make-up numbers because it gives you numbers already. So you could feasibly just type this into your calculator really carefully. But if you're fairly decent with fractions, then this might be quicker to do by hand. Okay, now this one's another good one that involves some critical thinking. For a real number x, the expression square root of x over 5 is an integer. You got to know what an integer is. Integer is just a whole number. Could be positive, could be negative, but it's a whole number. Each of the following expressions must also be integers except, well, if this is an integer, okay, let's pretend that it's 1. 1 squared is 1. That's an integer. Down here, this square root of x over 5, this is an integer because it's this up here. So this times 6, it's going to be 6 or, whatever. Let's pretend that the integer is 1 again. It's going to be 6. So we really only need to check B, C, and E. So let's think a little deeper about this. If this number divided by 5 is a whole number, that means that this is a multiple of 5 once it's simplified. So let's just pretend that it is 5. So let's pretend that square root of x is 5. Well, 10 times 5, that would be a whole number. 5 divided by 25 would not be a whole number. Negative 5 would be a whole number. Okay, so the answer is going to be C. So let me roll through that explanation one more time because this one was a little bit more complicated. If I know that the square root of x over 5 is a whole number, I'm going to make it an easy whole number to kind of imagine with. So let's make it 1. If it's going to be 1, the square root of x has to simplify to 5 also. So that means x is going to be 25. You just kind of pick a smart number to plug in there and test out your answer choices to see which one is not going to be an integer. Any questions on that one? All right. So this is a great question. Which of the following values of x satisfies the inequality 3 over 2 is less than x is less than 5 over 2? Well, x cannot equal 3 over 2 and it cannot equal 5 over 2. Please notice all of these are under a radical, even if they don't have to be. Also, please notice they increase from smallest to greatest because they're all under the same radical. You can tell that. So square root of 9 is smaller than square root of 20 is smaller than square root of 25. So the first thing I want to do is if they go in order, I want to simplify the ones that can be simplified. So the square root of 9 over 2, that's going to be 3 over 2. That is the low end of my range, and it cannot happen because this is just less than, not less than or equal to. So it can't be A. And then 25 over 2, square root of 25 is what? 5. Well, so if that's 5 over 2, that's the high end of my range, and that can't happen either. So it's got to be square root of 20 over 2. Didn't have to type a thing in the calculator, just be like, oh, hey, these match. It's got to be in between that. And conveniently, your numbers are in order. Okay? This one, I recommend you use your calculator for. Most folks don't do cubed roots in their head very well. Cubed roots are just not ones that we know. So if x is a real number such that x cubed is 729, the first thing you want to do is find out what x is, because then you're going to square it. There's not a real good formula for turning a cube into a square. So you, in your calculator, you do the yellow button and then the button over a couple from the 4, the little caret that we talked about earlier, and you type in the cubed root of 729. And I think it comes out to 9. So x is 9. And then you just plug in 9 squared plus the square root of 9. So 9 squared is 81. Square root of 9 is 3. So the answer is D, 84. Almost there. This is a great question too. It's fairly simple. This is going to be one that you want to plug in the numbers. And you've got 3 times the square root of y and 8 plus the square root of y that are going to be the same. Now, do you have to solve it by plugging in numbers? No. But the way that you would otherwise solve it is you would have to square both sides. One side's a binomial, so then it's going to have a lot of terms. It's going to make it long and complicated. So this one is best if you just plug in some numbers. Personally, I'm going to start with some numbers that are already perfect squares. Also, since these go in order, I'm going to start with C, just kind of see how it works out. So square root of 16 is 4. 4 plus 8 is 12. Square root of 16 is 4. 4 times 3 is 12. And conveniently, that's the one that we need to pick. So C, 16. If you had tried something else, like let's say you start with 4. Square root of 4 is 2. 2 plus 8 is 10. 3 times 2 is 6. 10 does not equal 6, so that does not work. And then you would just continue finding the one that does. Okay, they give us a value for k, and then you have to simplify for x and y. So on this one, let me find my top of my paper. There we go. On this one, we have x plus y over k, all of that squared, but we know that k is -1. So -1 squared, -1 times -1 is +1. So if it's all just over 1, we don't really need that part. So what it really comes down to is, do you know how to square x plus y, and how quickly can you do it? Notice over here, we are adding our terms compared to our earlier problems where we were multiplying our terms. When you're multiplying your terms, you're just going to distribute your exponents. But that's not what we're doing here. We're adding terms. So this is actually the same as x plus y times x plus y. And this is a problem that needs to be FOILed. So let me give you a shortcut for foiling the same thing times itself. Every single time, whether it's letters or whether it's numbers, the FOIL will come out to this. The first item squared, and then I do the last item squared, and then leave a gap for the stuff in the middle. So I'm going to go check these first and make sure that everything starts with x squared and y squared. And these are all positive, so I should have all positives. So A is out, B doesn't have a third term, D has negatives, E has negatives. The answer is C. Now, to go ahead and finish the pattern, because sometimes you will need all 3 terms, the way to do the middle is you're going to multiply these 2 things times each other and then double it. That's your O and your I in FOIL. So x times y, that's what I told you to do, right? You have O and I, your outside terms, x times y, x times y. So it's going to come out 2xy. And since both of your signs are positive, these are all positive. So questions on that? Okay. X is 1/2. It's also an exponent and it's negative. So really, I'm looking for a positive exponent in the denominator of a fraction. And the 1/2 power is a square root. So I'm going to start looking kind of down here. The one that's in the denominator is this. So I'm going to check this first. It's in the denominator. It's 2y minus 1. The square root is the 1/2 power. And the fact that it's in the denominator came from the fact that it was negative up here. So all of my little parts check out, and it's E. You didn't have to write anything. Okay, here's another one of those where you square it. So because I'm knowing the pattern and I'm fairly decent with it, let's just check it without writing it down if we can. 3n, and we're going to square both of those. So it's going to be 9n squared in the front. It means A is out and B is out. 5 squared is the back. 5 squared is 25. So C is out. So it's just between 15n and 30n in the middle. I'm going to multiply these 2 together and then double it. So 3 times 5 is 15, and then double it to 30. So E. And think about how much quicker that was than sitting writing 3n plus 5, 3n plus 5. Draw your line for F, multiply it. Draw your line for O, multiply it. Draw your line for I, multiply it. Draw your line for L, multiply it. Add the O's and I's together. Like that's a whole lot quicker if you know that pattern. So you don't necessarily need a strategy. You just need to know the shortcut or the pattern. Okay, same here. We're going to square the whole thing. So not square 1/3, not square A, not square B, but 1/3 A minus B times 1/3 A minus B. So the same pattern we've been doing. 1/3 times 1/3 is 1/9. A times A is A squared because we square the first term. A and B are the only ones possible after you do that. B squared is going to be the back. They both have B squared. Well, we know it needs to have 3 terms, so it's got to be B. If you wanted to verify it, you would multiply 1/3 A times negative B and then double it. So negative 1/3 AB times 2 would be negative 2/3 AB, just like it says. But you could just do it purely based on the number of terms for the difference between A and B. Okay, this one is probably quickest in your calculator unless you're really good at factoring. 48 and 27 need to be factored and simplified in order to do it by hand. So 48, 27, 8 times 6 is 48. That's 2 times 2 times 2, and that's 2 times 3. So I can take out 2 groups of 2, which is a 4, and the 3 stays under the radical. 27 is 3 times 3 times 3. So a 3 comes out and a 3 stays under. 4 of these minus 3 of these leaves 1 of these. So square root of 3 is your answer. If you want to type it in the calculator, that's fine. Once again, see what this decimal equivalent is. And since these go in order, start with the middle and see if it's too high, too low, or just right. If the middle was too big, it would have to be B because it's obviously not 0. If the middle was too small, then it's either going to be one of these two. You check one and pick your answer based on it. Oh, and that's the end. Say what? What happened to the 4? 4 of these minus 1 of these. It's like saying 4x minus 3x. Oops. 4x minus 3x would be 1x. So this 4 was, it's like an understood 1. Thank you for asking. I appreciate that. Other questions? All right. Let's stop our video.